Yes, yes. Then I start the record. Okay, first live code. I'm so excited and I just can't hide it. It's going to be a very simple vanilla RNN example, guys. We are going to cover a vanilla RNN example. It's going to be a real example. We are going to test different things and we are going to get the results. So let's start. I'm really so excited. So guys, we'll be implementing a simple recurrent neural network character model, which means the sequences will be characters, okay? And the output will be characters as well. We are going to create a one-to-one model in which when I feed a character, it's going to tell me the next character. So I'm going to provide a sequence of characters and it's going to provide me a fixed length character. So I'm going to say, hey, it's going to tell me, hey, how are you, kind of. And I'm going to provide the necessary input for that thing so that it will do its job. Okay. What I'm going to do is in my code, this is the first time you're seeing a Python code, what I'm doing is I'm providing the main libraries. So this is how you define your libraries in a Python code. I'm using NumPy as usual because it's like the basic mathematical operations similar to MATLAB operations in Python. And I'm also using PyTorch, nothing else. I'm using PyTorch and I'm using NumPy because it's a very simple example. First, I'm creating the input, the training set. The training set will be a bunch of sentences. I can make it longer. I can add training set sentences. So let's add something. Any suggestions? Any suggestions to add? Any suggestions?
It's good to see you.
Let's say it is good to see you. Okay, so this is a very simple example in which I provide some sentences, guys. I'm going to teach these sentences in a one-character input to one-character output model. So it's going to be a one-to-one model. I'm sorry, guys. The training set will be we can make it grow. We can make it read from a test file and it will, but I'm using a vanilla RNN, so it most probably won't have the capacity to do what I will ask him to do, but it's going to do funny things, by the way. So this is my input text. So I'm going to be going over the code in debug mode because this Spider interface provides a debug mode just like MATLAB. Things will be very easy for me in that sense. I'm going to show you what's going on in that debug mode. So this is the text. So if I say this is like a command window. So I just said it's text. Good. These are my texts. A bunch of variables. Okay. So what I do is I call, since this is a string, a built-in function join, which will provide me the unique characters inside this list of characters. So if I just move one step ahead, characters will be the unique characters in my data set. For example, there is no Z in my data set because I haven't used the character Z in any of my examples in the training set. If I add something, it's going to add it. If any of you cannot carry on, please, you cannot follow, please let me know, okay? Then I'm going to create a dictionary out of this. So int to char dictionary. So int to char will be this dictionary. In a dictionary, what you're doing is you're assigning numbers to these characters. This will be useful for us to feed the examples to the model. Okay, so 0 will mean N, 1 will mean M, 2 will mean G. I'm going to use this information because I'm going to create vectors. And I create the opposite dictionary as well. I'm going to need it as well because as you can see, the char to int dictionary will be the other mapping. So N will be 0. So whenever I want to map one thing to another, I'm going to use these mappings into char and char to int. They will help me because this is a This is a simplified character set. It doesn't include all the characters. It has the characters only in my training set. So I'm making my world limited to this set. Okay, so I have, starting from 0 to 18, 19 characters in my sets. And I've created them. If you print them, it's going to print them. So it's printing them. So I'm getting the maximum length of this text. Sorry, max len is 21, which is, guys, actually, I am creating, if you look, this, hey, how are you, is 15 characters. Good and fine is 14 characters. How do I know? I have counted. And it's good to see you. It's 21 characters. I'm getting this information because I'm going to make life easy for me for this example. I am going to pad small blank spaces to these ones like this, and I'm going to make each one of them 21. You may ask, why are you doing this? I mean, RNNs can take any kind of input variable length. Why are you doing this? Yes, they can, but to make this example simple, because I'm going to train each sentence once, and I'm going to do the training with a non-truncated fashion, which means I'm going to be running 21 length sequence and 21 length sequence back in training, these four different sets. That's why first I get the number 21. Then in this place, I am padding blank spaces to those who are shorter than 21. So let me do it. Okay, so the list is created. I have the inputs. So it's just adding it. No, let's not do it. So I'm going to put a breakpoint here and I'm going to jump there. So it's created. So if I get to my data set, which was text, you can see they're all 21 character long now. Any questions up to now? Good. Now what I'm going to do is I'm going to create a type of data structure in Python, which is a list. I need them to be lists because I'm using Python structures in Torch, and I need to convert them to these data types. Actually, for that sense, this example is quite beneficial for you, because if you want to use PyTorch, you know the theoretical means. Okay, RNN, I'm going to feed an RNN, but how? What kind of data types or variables it use? Here's, you got the example. So I'm going to go, I don't need to use the keyboard. So I'm going to be formatting using format. I'm going to jump here and show you what is those variables. So I have created an input sequence, which is this, as you can see. I've converted them to some sequences, but be careful, guys. It is good to see you. Although it is good to see you originally. I did something that this example did from GitHub did. What it is all the input sequences are trimmed at the end, and all the output sequences are actually trimmed from the beginning. So it is, output target sec it is, target sec. So, hey, how are you? Good, I'm fine. Have a nice day. It is a good day. See you. The reason is I'm going to use these input sequences and target sequences to train the network, which is one-to-one. How am I going to train it? I'm going to say that if I give you H, the next one should be A. If I give you E, next one should be Y. If I give you blank, the next one should be, what was it? Blank. No. If I give you Y, the next one should be blank. If I give you blank, the next one. So I'm just making it input and output. And as you can see, the last characters in the input are not included in the input sequence because there is nothing to teach after them. That's why I'm creating this input and target sequences. Any questions? Why did I create it this way? Because this is actually how I construct the architecture. Any questions? I'm going to feed A, hey, how are you, with one less blank, and the output will be A, how are you, with one more blank. The best example is it is good to see you, which is this is good to see you. So I'm just moving them like this so that each will be its input and output relation. Okay. So we have the inputs, guys. I'm going to do something here. I am going to turn them into input sequences. These input sequences. Sorry, guys. Okay, so where am I? Sorry about that. So there's another input operation that I'm going to show you. Input seg. So the input seg here, just we did here this part, is converted to numbers. Remember that definition we had here? We had int to char, remember? That list. By using that list, I've converted my characters to numbers. They already have numbers in the ASCII code, but I didn't use them. I'm confining myself to my single set. So this is my space, okay? So that the problem will be easier. So actually, this is the input set. Do you remember the input set, which was A, how are you? So A should be 15. Is it 15? You can check it into char. Yes. E, what is it? E is 3. What is it? E is 3. Input seg. So just let me solve this one. Actually, this is H 15. 15 is H. So it's, why does it start with H?
Because it's the input sequence.
Okay, but yes, that's the input sequence. We trimmed at the end. I'm sorry. You're definitely right. Towards the end, we don't have the last one. So the last one is, it is good to see you, as you remember. It's good to say you. And the last one is 8, which is O. Thank you very much, Ali. Sometimes I lose it and you're there. So we just converted these to these dictionary numbers. Good. One final thing I do. Okay, this is a network. I'm going to open up a blank sheet. New share a whiteboard. Can you see my whiteboard, guys?
Yes.
Yeah.
Yes, wonderful. Okay, because I've changed pictures. So this is the whiteboard. Let me move this. Please move. Please move. So what we are doing is we have a RNN. I'm feeding a character to it, and I'm getting a character out. And as I feed new characters, I'm getting an output. That's the idea. And the way I'm training is I feed A, it's A, and A, hey. Y, empty. Okay, this is how I train it. This is how I'm going to train it. And I've converted these to numbers like 8 or 3 or 18, remember? I can feed these numbers, guys, but is it a good idea? Instead, I can choose to feed this instead of 8. Remember my dictionary length, it was, my dictionary length was 18. Remember 18, 19 for 0 to 18, 19 different values. So instead of that, instead of 8, I can do something like a vector, which is all zeros, and 8 is 1 and others are zeros. Instead of 8, I can use this. Why would I do such a thing? I'm saying that it is better to do this way with this vector. Why? Any ideas? I'm going to explain it, but if you have ideas, I'd like to.
It will form a sparse matrix.
Sparse matrix. Yes, it being sparse is important, but in the other case, şu anda bir şey yok değil mi arkadaşlar? In the other case, can you see the code now?
Yes.
Yes. Okay.
Yes.
In the other case, we have one number. You are feeding 8 and 3 and 7. Those are mathematical numbers as well. Why feed vector like that? Can it be better? Okay, it's a difficult question, guys. Actually, it's related to natural language processing, which we are not going to cover much. But guys, in my dictionary, N is 0, M is 1, G is 2, E is 3. Conceptually, N or M or G as characters are not close to each other than they are to other characters like Y or F. However, if you define them as 0 or 1, they become closer to each other because 0 or 1 is mathematically closer. If you're feeding a value to a mathematical model like this, 0 or 1, or 3 or 5, the mathematical model would think that, well, they are closer to each other. It's 4, it's closer to 5, so they should be similar. It thinks that M and G are similar type of inputs. We don't want it to think that way. These are separate type of inputs. I am making them, in terms of linear systems, orthogonal by using vectors which are all zeros and ones, which are all bases of their own, and 0, 0, and 1. And if you use that base, if you take the dot product, any of the dot product will be 0, which will make all of my inputs orthogonal to each other. Any questions? And this part, I'm going to use this function to convert them to those vectors, guys. Python is a strange language, guys. I've never seen this before Python. In C, you don't have this. In Java, you don't have this. In MATLAB, you don't have this. In other primitive languages, you don't have this. You can define a function somewhere in your code, and you can use it after you define it. So in the middle of the code, you define a function as if it just came to your head. I just needed this function, let me write it. And you use it here. So as you can see, this is a function definition. That's why when you debug, it's going to jump. I've come to the definition here. It's going to jump immediately to here because that's a definition. So it's going to jump here. If you're going to go into the code, then you're going to be debugging here. So this one hot encode will convert my sequences to those vectors. Let me show you. So the input sequence was, let me show you. Where is the input sequence? Sorry. Where is the input sequence? This is input chart. This is the input sequence. It was this 15 or 3 or 18. Now the input sequence is something different. I'm going to show you the input sequence from the variable manager. This guy has a very nice variable manager, guys. Input sequence. I'm going to open the input sequence. So its shape is 4 by 20 by 19, which means for 4 different things, I have this. So as you can see, the first one was 15. So it will be 0 to 1. So 15 being 1. The second one was 3, 3 being 1. The third one was 18, 18 being 1. As you can see, it converted it to those vectors which are orthogonal. I've created an orthogonal base. I'm going to feed those orthogonal vectors as the inputs. I have this at the input 4 by 20 by 19. And similarly for the targets, I do the same thing. Okay, the input sequence, it's going to print it, so you have the printed versions here. Now be careful, guys. I'm going to use a PyTorch function, which is from torch to pi, from NumPy. It's going to convert my input sequence to a data variable type, which is compatible with PyTorch functions. So I will be able to use it for training. So if you do this, you will be able to see the same vector here as a matrix dimension. And if you most probably get the shape of it. I don't remember, but to see the shape, yes, the shape of it. So it will give you not size, torch size. However, when you want to try to see it from the input variable editor, it's going to provide a different type of interface because this variable editor is suitable for viewing NumPy variables. Now it's not a NumPy variable, it's a torch variable now. It has different properties, and this editor is not suitable for showing it, but still in the command window, you can just observe that variable. Good. I'm going to do it same thing for the out. So is CUDA available? Guys, it's a big no. Let me show you is CUDA. I don't have we got two servers, very nice server, but this is my desktop, so I don't have it. I'm using CPU. Okay, this is the model definition. So this is the model, guys, actually. And in this model, I have an RNN with hidden dimensions and n number of layers, and a linear layer. If you see the forward function, where's the forward function? Is here. It is an RNN connected to, output of the RNN connected to the linear layer. So we are going to use this model to create it. So this is how you create models in PyTorch. I'm going to continue that code. I'm creating the model here. Let me create the model. So I've got the model here. Model is an RNN with 19 input, 12 hidden variables, and 19 output, guys. So this is basically, if you look at this definition, it is going to be the input n being equal to 19. So it is like 0, 0, 0s, 1s, and k being equal to 12, because that's how I selected it, and n being equal to 12 again. So the output will be something 0, 0, 0s, 1, 0, 0s, indicating a letter. That's exactly how I put it. The rest is to find these weights. Okay.
I have a question.
Please.
When you choose the output size 12, does that mean you omitted some of the letters?
I didn't choose the output size 12. The output size is the same as the input size. I've chosen the hidden length.
I'm sorry, hidden names.
Right.
Okay.
I'm thinking that the number of states to represent my training set operation, 12 will be sufficient. Actually, 12 is not the number of letters. It is the number of states. What does states mean? Actually, in your homework, you're going to totally understand what state is. That's the purpose of the homework. It is like when it says, hey, I'm going to jump to that state. When it says, hi, I'm going to jump to the other state. If you increase the states with an increased training set, you'll get better results. So finding the number of states is a hyperparameter search, and it's heuristic and it needs some search. Answer to your question?
Okay, thank you.
Okay. Good question. And these are, I'm going to train it using some optimizer. I'm going to train for 100 epochs, which means I'm going to go over the training set 100 times. I'll have a learning rate of 10 to the minus 2, which is quite fast. And I'm going to use cross entropy loss. Cross entropy loss is, so between two discrete probability distributions, because you see this will be 0, 0, 0, 1, 0. It is like a probability distribution. So the ground truth will be 0, 0, 0, 1, 0. So it will be cross entropy loss. Actually, since all the inputs and outputs are orthogonal, it's going to be a value. Well, this will be a score actually. It's not going to be 0. This will be very many values. We'll try to push those values to 0s and 1s using the cross entropy loss. Good. And I'm not using the guy who have created the code, using adaptive gradient descent with momentum algorithm. You remember Adam from the previous semester. Okay, now I'm sending the input sequence to device. If it's a GPU, I'm sending that input training data to the proper places in the GPU cache. It is not, it's CPU. I'm sending it to the memory cache. It's all been done by PyTorch, so don't worry. Since this input sec is a PyTorch tensor now, any PyTorch tensor has this method which is called to, which means where are you sending to? And inside you'll have a device like CPU or GPU. So PyTorch is programmed such that it's going to put it in the proper cache so that you'll have very fast operation. So guys, this is the training. The nice thing about PyTorch is You do your training. You design your gradient descent. You design your backpropagation. You can design the flow of information. So it's simply, you do the forward run here. You do the forward run. This is the forward run. Then you get the output. You calculate the loss using the targets. Then using the loss backward function, you have some update values. You optimize the updates using the optimizer. So these are all, you can change it, you can get another loss. So you can create another flow here. But this is done this way. I'm not going to go into the details of the training and backpropagation in Python, but when you're doing your own project on PyTorch, you'll have to learn about these functions. For example, there are things, so you first make the gradients 0 before each epoch so that the gradients, updated gradients from the previous epoch does not change your values. And there are a lot of stuff that you have to learn about PyTorch gradients, but that's one example that you can work on. Very good. And now while I'm training for epochs, I'm printing some things out so that you can observe the progress of the training. Good. Then finally, there's another definition for predict, which means I'm going to be sending a value and it's going to output a value for me, which I'm going to be testing the model. And actually using these two functions, predict and sample, I'm going to send the model a sample, for example, and I'm going to get the result. First, let's choose something from the data set. Let's choose hey, because it was hey, as far as I remember, right? Sorry. Hey, how are you? Good, I'm fine. Have a nice day. It's good to see you. Let's choose hey. So let's see, because it's going to print the result. Let's choose hey. Say. I'm running it. Are you ready? No answer for hey, please. It's 15, so it's going to be 19. Hey, you. Sorry, it's going to be 21, I guess. It couldn't learn, guys. I'm going to make the problem simpler. I'm going to, Ali, I'm going to take your sentence first because it was much, it couldn't handle it. It couldn't handle it. So I'm going to train with this. So it was 15. So because we trained it with not 21, 15, because I changed the lengths. Now the longest one is 15. So I'm going to ask for it to run 15 times. So, okay. So it is memorized. Hey, how are you? What did we have also? Hi. We had hi, right? Sorry. Changing the wrong place. Hi. So it could memorize hi. It could memorize, did we have hi? No. Have a nice day and good. Okay, let's choose good. I'm going to do the other examples, don't worry. Let's say good. Good, I am fine. And what was the next one? Have. It could learn these. Have a nice day. Now let's try other things. For example, I'll try say. And it's going to give me an error because I don't have S in my space. I should choose a character in my space. If I needed S, I needed to have given an example which included S. I'm going to provide something nice like dude. And it's going to give me, dude, you find the. I've worked on these examples. They are so nice because it is like teenagers texting. Because when teenagers text, things like this happen and I don't understand. So I'm going to give you another example. For example, dad. It's a nice one example. That nice, yeah, you, yeah. Again, my teenage daughter is answering my text and I don't understand. And if I run the same example again, since I'm training over and over again in a stochastic manner, why? Because the batches are randomized each time I train. I'm getting something else that I know that you. Most probably she's asking something for me, money, because she's my teenage daughter. So let's try something else like hi. Let me try this hi. Hi, how am I? I am still looking nice. But when we change, Ali's example was very nice because we have made the problem harder when we did that. It couldn't handle it. It is good to see you. I'm going to do this. I've never tried this. I'm trying this online. But I'm going to change a couple of things, guys. I'm going to, for example, increase the dimensions so that it will be able to hold more states. And I'm going to train it for 200 epochs now. So let's see what's going to happen. High VNA is still slang words, but let's give the examples. Could it memorize the training set? Yes, this time it could have. Wonderful. Now we have some, because the previous time it couldn't, remember? Good. Good, I found very good. So let's start our dude example. Dude didn't give anything. So at some point it's feeding us, actually it's feeding a 15 character, but it's feeding us blanks. That's how it ended. That it's not. So in this training set, it came to a point in training in which if I don't understand what's going on, I'm going to provide blanks, which is nice, by the way. Okay, 21, let's say 21. 21. So because there are 21, I'm going to go for 21. Dadamov, see you. She's most probably going to see her friends before coming to home before work, before school. Okay, so this is fun when I tried it.
This is actually meaningful.
That's good. What is it? Dadamov, see you.
then I'm off. See you.
I hate you kind of sentence. You're definitely right. So what I'm trying to say is, guys, this is a very nice example of character array. With this example, changing this example, actually you can create your project. Imagine you have MIDI files. You know what a MIDI file is? In music, MIDI files are some files that's showing sheet notes of some songs. Imagine you have found some piano songs. You can just provide them like this, like a string of sentences, and you can change this network, which can read many MIDI files, and will provide you a new song, and you will listen to it. Or you can change this to words and just do the Andrew Benji's example. Or in Stanford's lessons, Karpati do the example on Shakespeare's sonnets, and they find very nice examples if you have watched those videos. You can change this to many things, and you don't have to do it using vanilla RNN. You can put an LSTM or a more complex structure, which we are going to learn in the following week. So for that reason, I find this example a very good starting point for your projects. And even you can change your project to a machine vision project in which you download a pre-trained network of CNN that you feed images to. Then you get the high-level features of that CNN and feed them. So video processing, for example, you can convert this to any example because it has the fundamental parts. Okay, so I'm thinking that this will be a nice place to start your projects. Any questions about the code?
Hocam benim bir sorum olacak ama.
Please.
Array yapısı ile ilgili sormak istiyorum.
About Python.
Çarpı 20 çarpı 19 olarak yazdık ama bunu bir çarpı olarak yazmamız gerekmiyor mu?
Which array? The array that we are feeding to the network?
Yo hocam eğitirken input
Yes.
sequence olabilir.
Well, actually the input sequence was, since we had 4 different samples, 4 by 20, because the longest sentence was 21, we have cut the end of each input, so it's 20 now, 4 by 20 by 19, because we had that vector zeros and ones of the vector length. So it's 4 by 20 by 19. Are you asking these vectors?
Hocam onu anladım ama ya sorum bunu upuzun bir cümle olarak vermek mi güzel ya da mi? Kısa olarak mı?
Well, it is, if you do that, actually, it is like you are truncating your backpropagation through time. And in order to truncate, that's like a truncation idea to me. That's similar to a truncation idea. What you do is you are changing your training loop. And you can change your training loop the way you say, and it will be a truncated backpropagation in time. But for this example, it doesn't seem useful because it could learn. Answer to your question?
Evet anladım. Teşekkürler.
Okay, any other questions?
Hocam ben bir şey önerebilir miyim denemek için?
Please.
Bizim setimizde olan herhangi şeylerden, harflerden random bir şey versek sonucu
Yes,
nasıl
please.
olur merak etmiştim.
Well, Murat, you can try this whole, but I'm going to try it for you. So what was a word? So let's say I. Yes, let's say I. You said a letter, so I'm going to give you a letter. The second one is a bit clever. If it doesn't find it, it is good to see you. So I'm going to say S. This time I have S because of the CU. See, it was very nice. We are using again teenage slang. We have created a teenage slang engine. Congratulations. Let me say, for example, what else could it be? What else? A. So let's see. So it is. It's very fun to play. It's still teenage slang. So as you can see, just guys try it, convert it, create your own project, play with it. That's the only way to learn Python and recurrent neural networks. In the following weeks, we are going to put LSTMs and do our stuff. And in the end, you're going to do a project and show it to me, guys. Okay? Okay. Okay.